All right, so this is a final exam review. You should absolutely know whether you have to take the final or not. The final is never a required test. So if you're not completely sure whether you have to take the final or not, and if you're not completely sure what you need to get on the final to get the grade that you'd like to get, shoot me an email, come visit me in my office, or talk to me in class, and I'll be able to tell you exactly what you need to get on the final, or if you can skip the final, because my finals are never ever required. So I'll just go through and do all the problems on the review. I'll do all the evens and odd problems. If you do all the problems on the review, you should be ready for the final. They looks kind of long. It looks like there's about 42 problems. So be prepared for a long haul here. I need to clear this parentheses. Since there isn't any adding or subtracting inside the parentheses, any number or letter without an exponent just needs to be squared, and any letter with an exponent needs to have its exponent multiplied by 2. So to clear that parentheses, I'm going to square the 5 and square the y. I'm going to multiply the exponent of the x by 2. And when you square the 5, you get 25. Multiply the exponents on the x's together, and you get a x to the 4th. And then we have a y squared. And that's all there is to that problem. That's the entire answer. There isn't anything else there is to do for that problem. 2 is a little bit harder, but it's just a matter of kind of doing the same problem twice. So I'm going to get rid of the first parentheses by cubing the 4, cubing the x, multiplying the exponent on the y by 3. I'm going to get rid of the second parentheses by squaring the 2, multiplying the exponent on the x by 2, and squaring the y. So now I have a problem that doesn't have any exponents. I'm going to do 4 cubed. If you can't do that in your head, use your calculator. That's 64. Now I have an x cubed, multiply the exponents on the y's and get a y to the 9th. It looks odd without a times sign here. I guess I could have this 4 written without a times sign, but I threw a times sign in, because 2 squared is 4. And then for the x, you get an x to the 10th, and we have the y to the 2nd power. Multiplication is commutative, so I'm just going to shuffle all the terms that need to be multiplied together next to each other. And you don't have to show this step if you can do this step in your head without putting everything next to each other that needs to be combined. But I combined the 64 and the 4, and those need to be multiplied, and that's regular multiplying. 64 times 4 is 256. For the letters, you add their exponents. So the 3 and the 10 on the x will add and give me an x to the 13th power, and the y to the 9th and the y to the 2nd will add to give me a y to the 11th power, and that's the best I can do for an answer to number 2. In problem 3, I need to reduce this fraction. It has a term with a negative exponent. This term that has a negative exponent, I'm going to get its exponent positive by moving it up to the numerator. And when I move it up to the numerator, it couldn't hurt to write it right next to the x it's going to wind up combining with. So I could put that x to the 4th power anywhere in the numerator because multiplication is commutative. 36. 36. Now I have to combine like terms and reduce the fraction. So I'm going to reduce this fraction, 24 over 36. If you can't reduce this in your head, you could just break your calculator out, turn your calculator on, enter the fraction 24 over 36, and you find out that reduces to 2/3. So in my answer, in the numerator, I'm going to have a 2. In the denominator, I'm going to have a 3. The x's are both in the numerator, so they're being multiplied, and I add their exponents. The first x in the numerator has an implied exponent of 1, and when I combine those, I get an x to the 5th. For the y's, because they're 1 in the numerator, 1 in the denominator, I subtract the exponents and leave the y where the larger exponent is. The bigger exponent on the y is in the numerator, so the y is going to wind up in the numerator. The y in the denominator has an exponent of 1. I subtract the exponents, 3 minus 1, and I get a 2 for the exponent of the y. It ends up in the numerator because the bigger exponent of the y is in the numerator. And that's the whole answer for number 3. On 4, we've got nasty fraction work to deal with. I need to get rid of the parentheses and then combine like terms. The first parentheses doesn't have an exponent, a multiplication, or a negative associated with it, so I can simply just drop that parentheses. The second parentheses, the minus in front of it, distributes, and you get a minus 3/4 x and a minus 4/3. Now I need to combine the 1/2 x and the minus 3/4 x and the plus 2/3 and the minus 4/3. I could, in fact, if I was doing this by myself, I would get a common denominator here on my x's and make this 2/4 x minus 3/4 x, and that would give me a minus 1/4 x. I don't care if you didn't want to do this fraction work by hand. You could do the fraction work part without the x's by going fraction 1/2 minus fraction 3/4, and you can get that minus 1/4 the same way. So there's my minus 1/4 x. The minus could be written directly to the left of the fraction, or it could be up in the numerator. It could even be in the denominator. The next two terms I need to combine, 2/3 minus 4/3, I just go 2 minus 4 and get a negative 2/3. And again, I could use my calculator to do fraction 2/3 minus fraction 4/3. I don't care if you do fraction work on your calculator. All right, so that would be the best answer for number 4. 5 is a tricky problem. It says multiply, and you can't just square the 3x and square the 2. When there's a plus sign inside of parentheses, you just can't apply the exponent to each term. To get number 5 simplified, I have to write it without the exponent, and something squared just means to multiply that by itself twice. And now I'm going to FOIL. First are going to be 3x times 3x, which is a 9x squared. Outers are going to be a 3x times a 2, which is a plus 6x. Inners are going to be a 2 times 3x, which is another plus 6x. And my last are going to be 2 times 2, which are a plus 4. For my answer, I'm just going to combine those terms. And I'm going to get 9x squared plus 12x plus 4 for my answer. I'm not going to factor that. If I factored that, it would go either back to that or to the original problem. And I want, because it says to multiply out, I'm not going to multiply it out and then refactor to get where I started from. All right, problem 6, another foiling problem. A little bit harder because of multiple letters. So firsts are 5x times 3x. That's a 15x squared. Outers are 5x times minus 2y. I multiply the 5 and the minus 2 and get a minus 10, and I leave the x and the y next to each other. The inners are 2y times 3x. They're both positive, so I get a plus sign. I multiply the 2 and the 3 and get a 6. I'll write the letters alphabetically and get a 6xy. And then the lasts, 2y times minus 2y. I multiply a positive 2 times a negative 2 and I get a negative 4. I multiply a positive y times a positive y and I get a y squared. The only thing I need to do to finish this problem up is combine these terms, and I combine them by just combining the coefficients. When you're adding or subtracting, the letters don't change, just the numbers in front do, and a negative 10 plus a positive 6 is a negative 4. So for my answer to number 6, I'm going to have a 15x squared, a minus 4xy, and a minus 4y squared. And again, I'm not going to factor that. If I factored it, it would go right back to the original problem. 7 through 12, my factoring, I have to remember my template and know whether I need bottoms up or not. My template for problem 7 is going to be a plus and a minus. My first just are a couple of x's. And my lasts have to multiply to 18 and subtract to be 7. So the numbers I'm going to finish up this problem with are the lasts, and they have to multiply. Technically, they multiply to negative 18. There's going to be 1 minus and 1 plus. And I say subtract because the signs are going to be opposite. When you subtract them, you'll get the positive 7. And my choices would be like positive 1 and negative 18. 1 minus 18 is negative 17. That's no good. Negative 1 times positive 18. 18 minus 1 is 17. Positive 2 times negative 9. And 2 minus 9 is negative 7. And negative 2 and positive 9. 9 minus 2 is positive 7. This is the pair that I need because negative 2 times 9 is negative 18. And 9 minus 2 is 7, which is the middle number. So the 9 gets attached to the plus, and the minus 2 gets attached to the minus. You can FOIL this out to check, but my videos, I know it's going to be a long video regardless of, and I don't want to do all the checking that you can do, but you certainly can FOIL that out to check it. 6 is nice because it's double plus. It's not nice because it's bottoms up. When there's a number in front of the x squared that you can't pull out as a common factor, that's when you use bottoms up. So the first step is to multiply in bottoms up. And I'm going to multiply this 6. It's multiply and rewrite, I guess would probably be the nice thing to say. And I'm going to get x squared plus 13x plus 30. That's my first step, so bottoms up. My second step is to factor what we produce on our first step. The nice thing about this is there aren't any minuses, so it's a double plus. No number in front of the x squared, so my first are a couple of x's. And whatever I put at the end after those plus sign, I call those the lasts. And they have to multiply to be 30 and add to be 13. And they're double pluses, so I can go 1 and 30. Those add to be 31. That's no good. 2 and 15 multiply to 30, but they add to 17. Those are no good. 3 and 10 do it. 3 and 10 multiply to 30, and 3 plus 10 is 13. So that's my lasts. I'm not done because the next step of bottoms up is the important step. And if you forget this step, you're going to have the wrong answer. And it's that 3-in-1 step. It's the divide, reduce, and bottoms up. Because on the first step I wound up multiplying by 6, on this last 3-in-1 step I need to divide by 6. And in this instance both fractions reduce, so I need to reduce both fractions. The fraction 3 over 6 reduces to 1/2. The fraction 10 over 6 reduces by 2 to 5/3. I've reduced both fractions, and now I'm going to double bottoms up. The 2 is going to bring up and go in front of the x. The 3 is going to go up and bring in front of the x. And the two parentheses I need are 2x plus 1 and 3x plus 5. If your answer was 3x plus 5 times 2x plus 1, it isn't any better or worse than mine. They're equally correct. So these are both correct answers. And it doesn't make any, whoops, you can't even see it. So those are both correct answers. So it's just a matter of what kind of, whatever you happen to write. I'm wondering if all that was on, yeah, it was all on the screen, I think. I'm just wondering if I floated off the screen. Number 9 is tricky. Number 9, there's a common factor. And always the first step in any factoring problem is to pull out the common factor. In a bottoms-up factoring problem, if you don't pull out the common factor, you won't get the right answer. So in problem 9, the first part of this is a 1 parentheses common factor factoring the common factor of 3. Because 9, 24, and 15 are all divisible by 3. I'm going to divide those by 3, and I'm going to be left with a 3n squared plus an 8n plus a 15. So when I finally go to write my answer, that common factor of 3 is going to remain in my answer, and then I'm going to get 2 parentheses. And the signs are going to be plus and plus, and I'm going to have to figure out what goes in those parentheses by using bottoms up. So to finish this problem out, I need to figure out how to factor the 3n squared plus 8n plus 15 part of what's remaining in the parentheses, and I do that by bottoms up. So my first step is going to be to multiply. I'm going to multiply this 3 and that 15. Oh, that should be a 5. I did 9 divided by 3 is 3, 24 divided by 3 is 8, 15 divided by 3. I should have written a 5 right there. So my goal now is to factor 3n squared plus 8n plus 5. Sorry about that. I started doing the bottoms up in my head maybe, or I just forgot to do something. So I haven't done the multiply part. The multiply part's going to make this n squared plus 8n plus 15. That's the multiply part of bottoms up. The second step in bottoms up is to factor into 2 parentheses what's left after you multiply. Signs are plus plus. There's no number in front of the n squared, so the first are a couple of n's. My lasts have to multiply to 15 and add to 8. The factors of 15 are 1 and 15, and 3 and 5, and 3 and 5 are the pair that are going to get me there. I could go 5 and 3, or I could go 3 and 5. There isn't a wrong way to do this. I did the 3 and 5 just because I just decided to, but a 5 and 3 would have been equally good. And now I need to do that 3 in 1 step, the divide, reduce, and bottoms up part of bottoms up factoring. I started off multiplying by 3, so I need to divide by 3. The first fraction completely reduces. It turns into an n plus 1. The second fraction doesn't reduce, and when a fraction doesn't reduce, you go straight into bottoms up that parentheses, and that will give me a 3n plus 5. And that's going to go in my answer. So in my answer, after the 3, I need one parentheses with an n plus 1 and another parentheses with a 3n plus 5. These can be switched. It wouldn't make any difference which of those parentheses you have first. On my answer key, I have the 3n plus 5 first. Ten is the easiest kind of factoring. It's a square with a minus. So you're going to get essentially 2 identical parentheses, one with a plus sign, the second with a minus. You're going to square root the numbers and divide the exponent of the letter by 2. So for the first number, the 25, I'm going to do the square root of 25, which is 5. That's going to go in the first part of each parentheses. And the exponent on the b, you're going to divide by 2. And you're going to get a b to the first to go along with that 5. So the square root of 25 is what, when you have a difference of squares, will go in the first here because the 25 is first. The letters, you divide the exponent by 2. And for the last, I just do the square root of 81. And the square root of 81 is 9. So for my answer, one parentheses needs a 5b plus 9. And another parentheses needs a 5b minus 9. And you could do 5b minus 9 first if you care to. It doesn't matter. 11 is a cube, and cubes are the hardest. I need to know my template and how to fill that template up. So what I'm going to do is write why this is a cube problem. X cubed is a cube because it's x times x times x. And 125 is a cube because it's 5 times 5 times 5. My template, the first parentheses has the same sign as my problem. Because this problem has a plus sign, the same sign of a plus is a plus. And then the second parentheses, you get the opposite sign of the first parentheses first. The opposite of plus is minus. And then the second parentheses always ends with a plus. And we did SOP, SOP, to figure out those same opposite plus. And now first parentheses, one of each. So I'm going to get one of the x's and one of the 5's. Second parentheses, pair and multiply. My first pair is x times x. And instead of writing x times x, I'm going to multiply those to be x squared. Second pair, x times 5. And instead of writing x times 5, I'm going to write 5 times x. And the last pair, 5 times 5. And instead of writing 5 times 5, I'm going to write 25. Second parentheses is always prime, and that's the whole answer to problem 11. For 12, I need to pull out the common factor of a negative 3. Actually, a negative 3x, because each of the numbers is divisible by 3. Each of the terms has an x, and the first term starts off with a negative. So I'm going to pull out a factor of negative 3x. I'm going to change that sign from negative to positive, that sign from negative to positive, this sign from positive to negative. When you're factoring out a negative, you switch all the signs. So that negative goes positive, that negative goes positive, that positive goes negative. I'm going to divide all the numbers by 3 and take an x away. 3 divided by 3 is 1. Take one of the 3 x's away, I'm left with an x squared. Middle piece, I already flipped the sign. 21 divided by 3 and you get a 7. It had 2 x's, I took 1 away, I'm left with 1x. 54 divided by 3 I think is 18. It is. It had an x, I took it away, so there's nothing left. So now I need to 2 parentheses factor what's left and keep that negative 3x in front. So what's left in the parentheses has a plus and a minus. The template for that is a plus and a minus. Don't need bottoms up because there's not a number in front of the x squared, so my firsts are going to be a couple of x's. And my lasts, I think we had these lasts already, they need to multiply to negative 18 and subtract to be positive 7, and that's going to be the 9 and negative 2, because 9 times negative 2 is negative 18, and 9 minus 2 is 7. So I'm going to get a plus 9 and a minus 2, and that will be my whole answer. So none of the problems up through 12 have had equal signs, so I haven't taken the time to take the parentheses and set them equal to 0. The next few problems have equal signs, and when we have problems that have factoring and equal signs, you're going to have to get numerical answers for x by taking each of the factors and setting them equal to 0. So problem 13 is factored and set equal to 0. I'm going to get 2 values for x because there's 2 factors. I'm going to set each of the factors equal to 0. When you set the 2x equal to 0, you divide both sides by 2. On the left side, the 2's cancel. On the right side, you get 0 over 2. That's equal to 0. But if I did 0 over 2 on my calculator, it would tell me it's 0. And then for the next x minus 3, I'm going to add 3 to both sides and get x equal to 3. You can leave your answer written like this, or I can write 1x and have the 2 numbers separated by a comma. That would be equivalently good. Fourteen's the same kind of problem in that it's set equal to 0, but it's not factored, so I need to factor it first. And then after I factor it, because you have the equal to 0 part, you're going to have to set the inside of each parenthesis equal to 0 and get numerical answers for x. I don't need bottoms up because there's not a number in front of the x squared. My firsts are going to be a couple of x's. The template that we have tells me the signs are plus and minus. And for my lasts, they have to multiply to negative 10 and subtract to be negative 3. And that's going to be 2 and minus 5, because 2 times minus 5 is negative 10, and 2 minus 5 is negative 3. So inside the parentheses, you get a positive 2 and a negative 5. I'm not done because there's an equal to 0, and anytime you have a problem that's factored and set equal to 0, you get numerical answers for x. I get those numerical answers by setting the contents of each parentheses equal to 0. For the x plus 2 parentheses, I minus 2 from both sides and get x equal to minus 2. For the x minus 5 parentheses, I add 5 to both sides and get x equal to 5. So my answer for problem 14 is x equal to negative 2 and positive 5. Of course, you could write it just like that if you want. For that matter, if you just wrote negative 2 comma 5 on your key and didn't write the x equal, I'd live with that just as well. 15 is similar. It's set equal to 0. There's a square I need to solve by factoring. I'm going to need to bottoms up the left side. So off to the side here, I need to figure out how to factor 5x squared plus 16x plus 3. First step is to multiply, because the number in front of the x squared is a 5, so I need to bottoms up. That gives me x squared plus 16x plus 15. Second step in bottoms up is factoring. I know this is easy to factor. There's not a number in front of the x squared, so my first are a couple of x's. The signs are just pluses, so my signs are a couple of pluses. This is a 16x. Makes a big, that should be 16x. My lasts have to multiply to 15 and add to 16, and that's 1 in 15, because 1 times 15 is 15, and 1 plus 16 is 16. I finish up my bottoms up by divide, reduce, and bottoms up. On the first stage of my bottoms up, I multiplied by 5. So on my divide, reduce, bottoms up part of this, I divide by 5. First fraction doesn't reduce, I go straight into bottoms upping. Second fraction does reduce, so I reduce it. So the initial problem, the 5x squared plus 16x plus 3, factors into 5x plus 1 times x plus 3. So I can rewrite my original problem as 5x plus 1 times x plus 3 equal to 0. Because I both have it factored and set equal to 0, I should split each factor up and set each one separately equal to 0. For the 5x plus 1 equal to 0, it's going to take 2 steps. I'm going to minus 1 from both sides and get 5x equal to minus 1. And then I'm going to divide both sides by 5 and get x equal to negative 1/5. For the x plus 3, I'm going to minus 3 from both sides and get x equal to minus 3. So for my answer to number 15, doesn't matter the order, but I'm going to write x equal to negative 1/5 and negative 3. It's only 25 minutes. I'm getting beat. For 16, it's factored but not set equal to 0, so we have to get rid of the factoring, set it equal to 0, and refactor before we can solve for x. So I'm going to clear the parentheses on the left side by going x times x and x times minus 1. That will give me x squared minus 1x on the left side equal to 20 on the right side. I'm going to set it equal to 0 by minusing 20 from both sides. That's going to give me x squared minus 1x minus 20 equals to 0. You certainly don't need the 1 in front of the x, but I kind of like it there. Template for this is a plus minus factoring, and I don't need to use bottoms up because there's not a number in front of the x squared. My first are going to be a couple of x's, and my lasts have to multiply to minus 20 and subtract to be negative 1. And that's going to be positive 4 and minus 5, because 4 times minus 5 is minus 20, and positive 4 minus 5 is negative 1. So inside my parentheses, I get a positive 4 and a minus 5. I shouldn't drop that equal to 0, so I'm going to bring that equal zeros down. Now that I have it factored and set equal to 0, then I'm going to take the inside of each parentheses and set them equal to 0. The left parentheses, I'm going to minus 4 from both sides and get x equal to negative 4 for an answer. The right parentheses, I'm going to add 5 to both sides and get x equal to 5 for an answer. So when I go to write my answer to problem 16, I'm going to write x equal to negative 4 and positive 5. Alright, so 17 wants me to find the domain of a fraction, and always to find the domain of a fraction, we ignore the numerator. So I'm going to ignore the 3. And I solve the denominator equal to 0. But that's not enough. Just solving the denominator equal to 0, it gets me the important number for my answer, but it's not written in a nice form. So the algebra for number 17 is just to take the h minus 5 and set it equal to 0, add 5 to both sides, and I get h equal to 5. The first thing I'm going to do is write my domain using words. And the template that we have used for every problem earlier in the semester, I can say the domain is all real numbers, or just say all numbers and skip the real. I can live with that. And then except 5. So that's one of the things that I need to have written. The second thing is I need the domain written in interval notation. So there's kind of two answers to problem 17, because I'm supposed to write the domain in words and in interval notation. To get the domain in interval notation, you start off with a number line that has negative infinity on the far left edge, positive infinity on the far right edge, and any number that you're excluding from the domain goes between the infinities. And then you put round brackets that kind of break the number line up into one more interval than there are numbers that you're excluding from the domain. I'm excluding one number from the domain, I'll need two intervals. If I was excluding two numbers from the domain, I would have three intervals. And now I'm just going to kind of just bring the numbers up and throw them in the parentheses. And so the domain in interval notation would be any number between negative infinity and 5, not including 5, and then again any number between 5 and infinity, not including the 5. And usually when we did the domain using interval notation, we put a union symbol between the distinct intervals. If you forgot the union symbol and didn't leave any symbol between the intervals or put a comma between them, I can live with it just fine. For 18, it's another domain question. It's a domain of a fraction, so I'm going to ignore the numerator. I'm going to do exactly what I started off doing in problem 17. The algebra is to take the denominator and set it equal to 0. This is a little bit harder to solve because there's a square and it needs to be factored. It's not bottoms up factoring because there's not a number in front of the y squared. It's no minuses, so it's a double plus. And my last have to multiply to 6 and add to 5, and 2 and 3 do that perfectly because 2 times 3 is 6 and 2 plus 3 is 5. Once I get this problem factored, I set the insides of each parentheses equal to 0. The left parentheses gives me y equal to minus 2 when you minus 2 from both sides. The right parentheses, when you set it equal to 0, you get y equal to minus 3. So I can write for my domain in words. My domain is all real numbers except -2 and -3. The interval notation is going to be a little bit trickier. I'm going to get 3 intervals. I always get one more interval than there are numbers to exclude from the domain. I start off putting negative infinity and positive infinity on the edges, and you can get messed up. -3 is further left than -2. If you have the -2 and the -3 flipped, then your answer might be wrong, but I probably wouldn't take points off. It would be wrong, but I wouldn't take points off. But -3 is to the left of -2 on the number line. And then I always expect to get one more interval than there are numbers to exclude from the domain. In problem 17, there was one number to exclude from the domain, so I got 2 intervals in my interval notation answer. In problem 18, there's 2 numbers to exclude from the domain, so I get 3 intervals. The first interval is going to be negative infinity to -3. The second interval from -3 to -2. The last interval from -2 to infinity. And for domains of fractions, it's always only round brackets. So that's the first part of my answer. The second part of my answer is, in interval notation, the domain is negative infinity to -3, union -3 to -2, union -2 to infinity. And it asks for both. My guess is on the final exam, I'll say find the domain, write your answer in interval notation or in words, and I'll give you the choice of what you want. But just to be safe, make sure you can do both ways. All right. 19 and 20 are reducing fractions, and reducing fractions are really factoring and canceling. So I need to be able to factor the numerator and the denominator, and both of these are supposed to be easy factorings. The numerator's a square with a minus, so you divide the exponent of the letter by 2, you square root the number. The exponent of the x2 divided by 2 would give me an x to the first power. So my firsts are going to be a couple of x's to the first power, so I'm just going to write the x. You don't need the exponent of 1. My signs are plus and minus, and my lasts I square root the 9, and the square root of 9 is 3. In the denominator, I don't need bottoms up because there's not a number in front of the x squared. My firsts are a couple of x's, and my signs are a couple of pluses, and my lasts need to multiply to 6 and add to 5. 2 times 3 is 6, 2 plus 3 is 5, so I'm going to get a plus 3 and a plus 2. And now any identical parentheses can cancel, or any identical factors can cancel. So those x plus 3's can cancel, but you can't cancel an x minus 3 at all with an x plus 2. Can't cancel the x's there. And that what's left is that didn't cancel is going to be my answer. And since I got rid of the factoring, I don't really need the parentheses anymore. For an answer, I'd probably write just x minus 3 over x plus 2. For 20, I've got to factor and cancel. The denominator is easy. The denominator, no bottoms up because there's not a number in front of the y squared. Signs are a plus and minus, and my lasts, they're going to multiply to -2 and subtract to be +1. And that's going to be a +2 and a -1, because 2 times -1 is -2. 2 minus 1 is the +1 that's implied in front of that y. So the denominator is the easier part of this. The numerator I need to bottoms up. So if I try to factor 2y squared plus y minus 6, bottoms up, first step, multiply. I get y squared plus y minus 12. Second step in bottoms up is the factor. There's no longer a number in front of the y squared, so my first are a couple of y's. My template gives me the signs are plus and minus. My lasts have to multiply to -12 and subtract to be 1. And that's going to be 4 and -3, because 4 times -3 is -12. 4 minus 3 is 1. So I get a +4 and a -3. I'm not done. I've only done the first 2 steps, and I need that 3 in 1 step of bottoms up, the divide, reduce, bottoms up. I started off multiplying by 2. I'm going to divide by 2. The first fraction reduces to y plus 2. Second fraction, I bottom up and get 2y minus 3. So in the numerator of my work, I'm going to change the numerator to y plus 2 times 2y minus 3, because that's exactly what the numerator factors into using the bottoms up factoring. And now I can cancel the y plus 2's. When I cancel the y plus 2's, I have my answer that's staring at me, and I don't need the parentheses anymore. So for my answer to problem 20, I'd probably just write 2y minus 3 over y minus 1, and that doesn't reduce anymore. 21 I'm not loving so much, but it is what it is. I'm going to deal with it. So 21's a multiplication problem, and multiplying is really just factoring and canceling as well. On my key, if you were peeking at my key, I didn't multiply out the numerator, but you might. But the first step in 21 is to factor anything that can be factored. So first thing I'm going to look at is this x squared minus 9. That's easy factoring. That's a square with a minus, so I divide the exponent by 2 and square root the number. That numerator factors into an x plus 3 and an x minus 3. This denominator doesn't have a square or any exponent, so it can't 2 parentheses factor. It doesn't have any common factors. It's not going to 1 parentheses factor. That denominator just doesn't factor. The 9x squared minus 16 is factor similar to x squared minus 9. It's a square with a minus. I'm going to square root the numbers, divide the exponents by 2. For the first parentheses, square root of 9 is 3. For the exponent of the x, 2 divided by 2 gives me an x to the first. And that's going to be in the first for each of my 2 parentheses. My signs are going to be plus and minus. My last, I take the square root of 16, and the square root of 16 is 4. In the denominator of this second fraction, I don't need bottoms up, but I need to factor it. There's no minuses, so my signs are a couple of pluses. My first are a couple of x's. My last have to multiply to 9 and add to 6. They're going to be 3 and 3, because 3 times 3 is 9, and 3 plus 3 is 6. So now I have the things factored, and I can cancel within the same fraction or between fractions, as long as I go top to bottom. So this 3x plus 4 and that 3x plus 4 will cancel. This x plus 3 will cancel, but it'll only cancel one of those x plus 3's out. And nothing else will cancel. An x plus 3 can't cancel an x minus 3, nor can it cancel a 3x minus 4. In my answer, I leave the numerator factored, but you can, it'd be completely fine to FOIL the numerator. But I'd say this is the best answer. But if you worked this problem ahead of me, and you got to this point and you FOILed out the numerator, it's completely okay. There isn't anything wrong with FOILing the numerator. It's just, it's not necessary, and it's better to leave your numerators factored. (22's a division problem, and in any division problem you have to make it a multiplication problem. So at some point I need to change problem 22 to a multiplication problem, and I make a division problem into a multiplication problem by taking the fraction that's after the division sign and I flip it. So I change the division sign to times, and I flip the fraction that's to the right of the division sign. There's not much factoring that can happen here. The 5y doesn't have any factoring that it can be done. The 4y minus 12 only has a common factor of a 4. The 6y minus 8, 18, has a common factor of a 6. And now when you divide each of these by 6, 6 divided by 6 leaves me just with a y. 18 divided by 6 leaves me with a 3. This denominator doesn't factor, but it might help it if I wrote the y squared as y times y. Now I can cross cancel, up and down cancel. This y minus 3 and that y minus 3 will cancel. This single y will cancel with one of those single y's. I can cross cancel this 5 with this 10. 5 divided by 5 is 1, but 10 divided by 5 is 2. I can cross cancel this 4 and this 6. 4 divided by 2 is 2. 6 divided by 2 is 3. So I've canceled everything I can possibly cancel. And in the numerator, the only thing that's left is this 3. So in my answer, in the numerator, there's going to be a 3. In the denominator, I have this 2, and that y left over. I'm going to multiply the 2's together and get a 4, and I'm going to leave the y. So 3 over 4y feels like the best answer for that. Yucko. 23 and 24 don't look so fun. So 23 and 24 are adding and subtracting fractions with unlike denominators. When fractions don't have like denominators, you need to make them have like denominators. And in order to figure out what the common denominator is, you need to factor any denominator that's not already factored. You don't have to worry about the numerators on the first step. So the first step to adding or subtracting fractions with unlike denominators is to factor any denominator that can be factored. That can't be factored. That factors into m minus 4 times m plus 4, or m plus 4 times m minus 4. Now I look at the two fractions. They both have an m minus 4 in common, but they both don't have an m plus 4. So I'm going to make the first fraction have that m plus 4 in its denominator. And in order to get the m plus 4 in the denominator, I also have to get the m plus 4 in the numerator. Because the problem doesn't have an equal sign, I can't clear the fractions. Now I'm going to multiply out the numerator of the first fraction and get 2m plus 8 over m minus 4 times m plus 4. And then minus, I'm going to say this is 1m minus 2, just because it's going to help me. I think seeing that 1m there is better than just seeing an m. Now I can make the two fractions into one, but the minus sign is going to make this crazy. The minus sign is going to attach to that and make it a minus 1m, and it's going to flip that sign and make it a positive 2. So the minus between the two fractions, when I go to make the two fractions into one, it messes up the signs in that right fraction's numerator, makes this a minus 1m and a positive 2. And then when you're adding or subtracting fractions that have the same denominators, the denominators don't change when you add or subtract them. Last step, I'm going to combine the 2m minus 1m, which gives me a 1m, or just an m, and the positive 8 and the positive 2, which give me a 10. So for my answer, my numerator is going to have an m and a plus 10, or a 1m and a plus 10. And then the denominator is going to have the two pieces, the m minus 4 and the m plus 4. And that's the whole answer. There isn't anything else I can do there. Yuck. 24 is worse, however. For 24, both denominators are factorable, so I need to factor them both. The left denominator, nothing but plus signs, so I'm going to get 2 parentheses with nothing but plus signs. I don't need bottoms up because there isn't a number in front of the b squared. My lasts have to multiply to 4 and add to 5. They're going to be 4 and 1. Second denominator, it's one of those 2 identical parentheses when you square root the number and divide the exponents by 2, and you get a b plus 4 and a b minus 4. Both sides have a b plus 4 in common, but they're not exactly in common because they're not ready to add because they don't have the same denominator. The first fraction is missing a b minus 4 in its denominator, and I'm going to give it that b minus 4 by multiplying the numerator and the denominator by b minus 4. The second fraction is missing the b plus 1 in its denominator, and I'm going to give it that b plus 1 by multiplying both the numerator and the denominator. Now I'm going to multiply out the numerators. I'm going to go 2 times b and 2 times minus 4 and get 2b minus 8. And then I'm going to write my left and right denominator in the same order. And it really doesn't matter. As long as you have the 3 factors, it doesn't matter the order that you write them in. I just chose this for my order. But as long as you have a b plus 4, a b minus 4, and a b plus 1, the order is not a deal breaker here. So I multiplied out the first numerator. I'm going to multiply out the second numerator by going 6 times b, which is 6b, 6 times 1, which is plus 6. Have both denominators they have the same 3 pieces in the same order. Now I can make the 2 fractions into 1, and when I make the 2 fractions into 1, I get minus 2b minus 8 plus 6b plus 6 over b plus 4 times b minus 4 times b plus 1. In the numerator, I'm going to add the 2b and the 6b to get an 8b. And I'm going to add or combine the minus 8 and the plus 6 to get a minus 2. So I would say a minus 2. A completely fine answer would be having it both an 8b and a minus 2 in the numerator over the 3 factors b plus 4, b minus 4, and b plus 1. It would be better if you noticed that the numerator had a common factor of a 2 and wrote 2 times 4b minus 1 in the numerator over the same b plus 4 times b minus 4 times b plus 1. But if you didn't catch that on a test because you're feeling rushed on a final exam, I wouldn't ding you any points for missing that fact that the numerator factored there, but it's kind of nice if you would have caught that. All right, 25 and 26, I need to clear fractions because there's a problem that has fractions and an equal sign. Anytime I have a problem with an equal sign, I need a numerical answer for x. And for this problem, I need to get rid of an x minus 2 and an x plus 4. I get rid of an x minus 2 and an x minus 4 by multiplying by an x minus 2 and an x plus 4. In this problem, I'm going to multiply each fraction by x minus 2 times x plus 4 over 1. This is very different than what I did in the last 2 problems because when a problem has an equal sign, you can clear the fractions rather than having to live with the fractions. So I take advantage of that. And when you have a problem with an equal sign, you know you're trying to get numerical answers for x. And when problems have equal signs and they have x's, and they have fractions, you need to clear the fractions. So my first canceling, I'm going to cancel the x minus 2's. My denominators are now going to be 1 times 1, which is 1. I don't need to write a fraction anymore for this first term because it only has 1's in the denominators. What I'm left with there is an x times x plus 4. Next piece, I'm going to cancel the x plus 4's. The x plus 4's turn into 1's when you cancel them. I only have 1's in the denominator. I don't need to write a fraction anymore. I'm going to bring down what didn't cancel, which is a 1 times x minus 2. And then to the right of the equal sign, the x minus 2's cancel. They turn into 1's. The denominator is only a 1 times 1, so I don't need to write a 1. I'm left with an x minus 8 times x plus 4. Now I need to get rid of all the multiplying. So I'm going to, or parentheses, I'm going to go x times x is x squared, x times 4 is plus 4x, 1 times x is plus 1x, 1 times minus 2 is minus 2. That's the left side. On the right side, I have to FOIL. I'm going to go x times x is x squared, x times positive 4 is positive 4x, minus 8 times x is minus 8x, minus 8 times 4 is minus 32. Now I'm going to combine the like terms on each side. 4x plus 1x is going to combine. The 4x minus 8x are going to combine. The left side is going to be x squared plus 5x minus 2. The right side is going to be x squared minus 4x minus 32. Usually when you have both an equal sign and a fraction, you have to solve by factoring. You need to get the problem set equal to 0. This is one of those special instances when that's not going to be the case. Because if I minus x squared from both sides, it's going to make the x squareds go away. It's going to make my need for factoring to go away. So I just did this one step to make it obvious that I don't have to factor in this problem 25, because the x squareds are going to cancel. Because the x squareds need to cancel, I need to get the numbers on one side, the letters on the other. I'm going to add 4x and add 2 to both sides. Adding 4x will make the letters go on the left side. Adding 2 will make the numbers go on the right side. So what I've forced to happen here is having 5x plus 4x is 9x. The 2's cancel. Minus 4 plus 4, the x's cancel. Negative 32 plus 2 is negative 30. And now I'm going to divide both sides by 9. On the left side, the 9's cancel. I'm left with an x. On the right side, that fraction reduces. If I did negative 30 divided by 9 on my calculator, did negative 30 in the numerator and 9 in the denominator, it reduces to negative 10/3. So the best answer for problem 25 is x equals negative 10/3. All right, 26 is similar in that I need to get rid of the fractions, but I don't have to factor. I'm going to leave myself some room. I need to get rid of a 3, an x, and a 6. Multiplying by a 6 will get rid of a 6, and it will get rid of a 3. So to get rid of the 6 and to get rid of the 3, I multiply by 6. To get rid of an x, I have to multiply by an x. And so I'm going to multiply each term by 6x over 1. And that should help me clear the fractions. First canceling I'm going to do, I'm going to cancel this 3 and this 6. The 3 is going to turn into a 1. The 6 is going to turn into a 2. Fractions are going to be gone because I only have 1's in the denominator. And I'm left with an x times 2x. I'm going to bring down this plus sign. Next piece, I'm going to cancel the x's. The x's turn into a 1. Fractions are gone because I only have 1 in the denominator, and I'm left with 1 times 6. To the right of the equal sign, cancel the 6, cancel the 6. I have 6 turn into 1's. I only have 1's in the denominator, so I don't need a fraction anymore. In the numerator, I'm just left with a 7 times x. So in one step, I've taken the problem that has fractions and gotten rid of the fractions. I haven't done the multiplying that I need to do yet. So I'm going to multiply x times 2x and get 2x squared, 1 times 6 and get 6, and 7 times x and get x. Now I have a problem that has an equal sign and a square, so I probably need to set it equal to 0 and solve by factoring. So I'm going to minus 7x from both sides and get 2x squared minus 7x plus 6 equal to 0. And then what I'd like to do is make the left side into 2 parentheses. And in order to get it there, I'm going to do bottoms up factoring. I'm going to do that right off to the side here. So here's my bottoms up factoring because the 2 in front of the x squared. So first step in bottoms up factoring is to multiply. That's going to give me x squared minus 7x plus 12 when I multiply the 2 and the 6. Then I have to factor this. This is a double minus factoring. My last have to multiply to 12 and add to negative 7. They're going to be minus 3 and minus 4 because minus 3 times minus 4 is positive 12. Minus 3 plus minus 4 is minus 7. So I'm almost done with the bottoms up factoring. I did the multiply step, I did the factor step, and now I'm going to do the divide, reduce, bottoms up. I started off multiplying by 2. I need to end up dividing by 2. This fraction doesn't reduce, so I bottoms up that and get a 2x minus 3. This fraction does reduce, so I reduce it and get an x minus 2. So my 2x squared minus 7x plus 6, it factors into 2x minus 3 times x minus 2. Now I have the left side factored and the right side equal to 0, so I take the insides of each parentheses and set each one separately equal to 0. The 2x minus 3 factor is going to take me 2 steps to get an answer. I'm going to add 3 to both sides and get a 2x equal to 3, and then divide both sides by 2 and get one answer of x equal to positive 3/2. The x minus 2 factor, I'm going to add 2 to both sides and get the second answer of x equal to 2. So for 26, my answer, this is 26 because it's kind of flown off the screen. My answer for 26 is x equal to 3/2 and 2. Now some word problems.